Okay, moving on to section 3.2, sum of the squares and cubes. So these two results, you need to memorize them. They are in the form, no, you don't need to really memorize them because they are, I think, in the formula booklet. It's the sum of natural numbers. Ours is not, so this one is the one you need to memorize. However, if you look very closely, there is a beautiful property of the sum of the cubes. If you square the sum of natural numbers, sum of r, you'll get sum of cubes. So when you look in the formula booklet and you see sum of cubes, you square root it, that will give you the sum of r. So let's have a look. So the first one, that tells me I need to take the sum of 40 terms and subtract the sum of first 19, because we start from 20. So we're going to use the sum of squares because we're doing r squared. So we're going to put, instead of n, 40 in the first one. So it's going to be 16 times 40 times 40 plus 1, so 41, times 40 times 2 plus 1, so times 81. So this one here is going to be 1/6 times 40 times 41 times 81. So it's 22140. And then if I put sum of 19 terms, so it's 19 times 20 times 39, because 2 times 19, add 1. So let's do that. It's 1/6 times 19 times 20 times 39. So it's 22,140 minus the previous answer gives me 19670. If you want to check whether your evaluation is correct, you can use the sigma notation. The sigma key somewhere here, there you go. Okay, so in here in the brackets where it's flashing, we've got to put the rule. So we're going to use, I think you need to use x squared, and we're going to put x, it tells you there that they call it x. We're going to start from 20 up to 40. You only use this to check your result. In order to gain your marks, you need to show clearly how you evaluated it, like I've shown you. Okay, here we're just going to use the sum of first 25 cubes, starting from the 1st to 25th. That means your n needs to be replaced with 25. So it's 25 and then 26 squared. So it's 25 squared times 26 squared, and I need to divide it all by 4. Okay, so it's 105,625. Okay, let's check whether our sigma notation gives me the same answer. So I need to go to alpha x, let's put to the power 3, starting from 1, going up to 25. So in example 6, we've got to show that the following result is true. Okay, so first of all, think about what it is. It's the sum of 2n terms, but we don't want the initial terms that, so we want to keep n plus 1, so you don't want initial n terms. Okay, so I want to have the sum of squares. So remember, the sum of squares is going to be 16, n plus 1, 2n plus 1. So if it's 2n, I'm going to replace each of my n with 2n. And this is going to be 2 times 2n, so it's 4n plus 1, minus, just copy this as it appears, 1/6 of n plus 1, 2n plus 1. Okay, so what I like to do, I just want to just use my colors because I am aiming for 1/6. So I want to keep that, although I could cancel this, but there's no need. I want to keep N, and I will also keep that. So what have I done there? I'm going to there's two terms here, this one minus this one. What do they have in common? Can be taken out in front of the bracket. So I have taken out 1/6, n, and 2n plus 1. The rest, whatever is remaining, can be put into brackets. So I've got two lots of this left, minus n plus 1. So it's 1/6 of n times 2n plus 1. And then you've got 8n minus n. Let me just write it without brackets. So hopefully it will be what we are aiming for. So it's 7n plus 1, which is what we have as required. Now, excuse me, for part B, I believe they are asking us to verify the result for n equals 1 and n equals 2. So what do they mean by that? Well, find what this is, the left-hand side. So for n equals 1, the left-hand side gives me the sum of all the terms. Now, if n is equal to 1 from the second, and this one will give me the second as well. Well, this is going to be just 2 squared. From the second to the second, you're just staying at one term. Okay, what about the right hand side? Do I get 4 as well if I put n equals 2 into this expression? So it's 1/6 times 2 times 2 times 2 plus 1 times 7 times 2 plus 1. Okay, I've just realized what I was doing wrong. We did use, I was looking at this one, so we're using n equals 1. So we are checking, substituting 1 instead of n. So this should be 1, this should be 1, this should be 1. So it's going to be 1/6 times 3 times 8. So that will cancel, and then this will cancel. There you go. 4. So they both are the same, so it's verified. Here we'll be using 2. So if you use n equals 2, the left hand side will generate. So carefully, if I put 2 in the bottom here, your r will start from 3, and your r will finish at 4. So what do I get if I just put 3, third and fourth one, because we need to stop at fourth one term. There you go. So that's going to be 9 plus 16, which is 25. But the right hand side is going to give me 1/6 times, now here we've got to put 2, so it's 2 times, so it's 2 times 2 plus 1, and then 7 times 2 plus 1. So that's going to give me 1/3 times 5 times 14, add 1, so 15. So it's the same. So it's been verified. You could say left hand side is equal to right hand side. Okay, 2 more examples. So example 7, again here we've got to have a show that question, and then we need to evaluate that sum. So to show that question, this time we've got a mixture of rules. So we've got the sum of squares. The sum of squares is 1/6 n 2n plus 1 n plus 1. I wrote it in the wrong order, but never mind. And then plus the sum of r, so this is going to be 1/2 n, n plus 1, and minus 2 written n times, so it's going to be 2n. Okay, so what can we do? We can take n out, and you can take 1/6 out, just for, so it's a bit simpler, because there's 1/6. So I'll change this one into a 6 by timesing that by 3, and this one I'll times by 6/6. Now I know we are aiming for a third, but at the moment I need to take what I can, and I don't want to be dealing with fractions. So it's 1/6, and n can be taken out. Let me show it with color. This one has 1/6n. This one will have 1/6n. There will be 3 left, and this one has 1/6n as well. So we're going to take these out. The rest can be put into brackets and tidied up. So what's left from the first term is 2n plus 1 times n plus 1. The second term you'll have 3 left and n plus 1. And the last term will have 2 and 6, so minus 12 left. Okay, I mean, you can always multiply it all out and then put it in brackets, because you know what you are aiming for. You could factorize n out and then factorize the brackets that's remaining. 2n squared plus 2n plus n is 3n, plus 1 plus 3n plus 3 minus 12. So it's 2n squared. You've got 6n, and you've got 4 minus 12, so it's minus 8. So here we can take 2 out. That's why that becomes a third. And you have n squared plus 3n minus 4, which will nicely factorize now to n plus 4 and n minus 1 as required or shown. Looking at part B, now they've written this sum in the expanded form. So what we need to from this, you need to work out what is the value of starting point, so the initial r, and what's the value at, for the end point. So here we can actually work out, if I put 1 into this, I'll have 1 squared plus 1 minus 2. So if I put 1 in, that will start with 0. So you may have had a 0 here, but maybe you can ignore that. What if I put 2 there? So it's 2 squared plus 2, so it's 6 minus 2, that's 4. So I can definitely start from 1 if I say that this starts from 0. What's the end point? I need to make my rth term equal to 418. So r squared add r minus 420 is equal to 0. So here we're going to factorize that. 42, difference of 21 and 20. Yeah, that should work. 21 and 20. That's going to give me positive minus. There you go. Okay, so r needs to be positive because it gives you the position in the sequence. So r minus 21 you're going to reject. So r needs to be 20. So that gives me how many terms we are adding. So it's 20. And the rule here is r squared plus r minus 2. So here, using the results from the previous part, we're going to substitute 20 into that. And you get 20 times 24 times 19. Pop it into the calculator. And you get 1/3 times 20 times 24 times 19. So it's 3040. Check with your sigma. So you're going to start, let's put this one in, so it's alpha squared plus alpha minus 2, starting from 1 up to 20. There you go. Okay, so that takes you to, I think there's one more example. Yeah, so one more example. Okay, example 8, we need to show that the sum of this cubic is equal to this expression, or can be expressed in terms of n. So, the first thing we're going to do, we're going to multiply out the left hand side. So you're going to have sigma 1 to n, so that's going to be 2r cubed. Then you're going to the 6r minus r, so 5r squared. And then you are going to have minus 3r. You're going to use 3 results: sum of cubes, sum of squares, and sum of natural numbers. So this one will be to 2 times the sum of cubes. Is, remember, it's the same as sum of natural numbers by the square, but it is in the formula booklet, so you can check. 1 squared, n plus 1 squared. The sum of squares is 1/6, n plus 1, 2n plus 1, and 3 lots of 1/2n times n plus 1. Okay, so it's up to you. You may want to expand it all. I never go for expanding, especially as we are aiming for a quartic, although you are given what common factors are, so you could always divide through if you need to. But I'm going to take 1/6 of n and n plus 1 out. So I'm going to, this one at the moment is a quarter, so if I cancel it, it's a half. I'm going to make it into 1/6, so times that by 3 and that by 3. This one has got 1/6, and this one here I need to times that by 3 and that by 3. So if I take out 1/6 of n, so I'm circling the bits that I'm taking out, so I'll circle a square because I'll be leaving n. So I'll have 1/6 of n, but I will also, I've noticed that n plus 1 is a common bracket, so I'll also take n plus 1 out. So I'll be getting rid of 1 of n plus 1, so I'm circling the squared. I will take that out of the question, and this as well. So whatever I haven't circled will need to be put into the big bracket and tidied up. So over here I've got 3n, n plus 1 left. 3n, n plus 1 left. Check whether these two, when times together, give me this expression. So 1/6 times 3 is a half. We did have a half. N times n is n squared. N plus 1 times n plus 1 is n plus 1 squared. That's correct. So this one here will be left with 5 and 2n plus 1. And this here will be minus 3 times 3, minus 9. Okay, so 1/6 of n, n plus 1. This big bracket over here needs to be tidied up, so expand the terms inside and then collect them together and factorize whatever you obtain. So let's just do it on the side. 3n squared plus 13n minus 4. Actually, we do not need to factorize it because we are told, specifically by having it written like this, that it does not factorize. Okay, so it's 3n squared plus 13n minus 4. So the value of A is 13, the value of B is minus 4. So here for the last part, part B, we need to use that result. It says hence, and find the value of the following. Okay, so we've just found the answer to this if you were summing n terms. So we've got 40 minus 10. Okay, so substitute 40 into this expression. 40 squared plus 13 times 40 minus 4, and subtract the sum of 10 terms. So it's 10 times 11, then you've got 3 times 10 squared plus 13 times 10 minus 4. Use your calculator to find the answer. So it's going to be 16, 40 times 41 times 3 times 40 squared plus 13 times 40 minus 4. Oh, made a mistake here. Times here. So 145. 1,453,040 minus, I'll just go back and change those 40s to 10s. This one will go to 11 and this one to 10. Okay, so it's 7,810. So I've got this, take away 7, 8, 10. So 1,445,230. Okay, don't just go straight away for the calculator to evaluate it, so jump straight away from this to the final answer, because you've used a calculator using Sigma key. Always go through substitution. Okay, so go to exercise 3b and then mixed exercise, so it's the end of chapter 3.